Hello everyone. Let us now discuss how can we solve this problem. Implement router. So first thing I'll explain you what is about the router and what are these packets and also what is given in the question. So router is something like a Wi-Fi port or is something like a device which sends the source device or source machine to destination machine with a timestamp. That means here we are having a source machine, a destination machine, and this router will send the packet of this from the source and to the destination. For example, you are something like here you are having a laptop here and there is something like a server for youtube.com and you are requesting youtube.com, and that means this needs a packet source and this is a destination of youtube. And when did you go for it? It is given in timestamp. That means when the does this request come? This is given in the timestamp. This is the whole thing about the router. And router is something like your Wi-Fi machine or something like that. So this is how the router, the source, destination, and timestamp work. Now let us see how does this router work actually. So first thing, this is the first uh, something like first thing that I get into the router. That means this is the first source, destination, and timestamp. So what does this router do? Router take this and forward this into the destination. That means this is forwarded into the destination. So this will be deleted, and then these two come here. So these two come here, and then the moment it is ready to forward, then it will be uh, taking this and forwarding it to the destination machine. But wait, here I need to consider two things. What if number of packets exceed memory limit? So this router will be having a memory limit like 3 or 4. Here if you see, if I am having only 3 as the memory limit, then there will be a conflict. So at that time the first uh, packet will be sent, then the next packet which is coming will be inserted at the back or pushed back. So if the number of packets limit exceeded, so pop front, else push back, push back. So this is how the algorithm for this router work. Now let us see this example of forward packet, add packet, and these all. Let me tell you that memory limit is given to me as something like, here I am having 5 as memory limit. Let us take 5 as memory limit. Now add packet, we are given with source, we are given with destination, we are given with the timestamp 110. That means the machine with one like device id or something like ip address 1 source, ip address will be stored, but I am saying you that just one ip address will be stored in source, and destination also contains the ip address of the destination. So the device 1 is sending a packet to device 100 at 10. That means a time of 10. So let me add this. Let me add a packet of let me add a packet of this having a source of 1 and destination of 100 and a timestamp of 10. Yes, I have added this successfully. Now let me understand what is given like this. Add the packet into the packets that are need to be sent, forwarded, return true. If it is duplicate, then return false. That means here these are that nothing that sent. That means here we'll be forwarding this packet. When we call this forward packet, this packet will be forwarded. That's why I wrote here forwarded. So let us see, if the packets exceed memory limit, remove the first packet. This is how first in first out works in operating systems. Now I have 110. Let us see, this is completed, right? This is completed. Now this is successfully executed. I am striking it off. Now I am having 1, 200 and 100. The source is 1, the destination is 200 and the timestamp is 10. Let us see whether this is a duplicate. That means this packet is coming again. So at that point we will return false. So here when we executed this add packet of 110, we need to return true. That's what this is asking for in add packet function, a method. Now I am having 1, 210. If you see, there is only one packet and it is not 1, 210. So what I'll do is consider the same, and here 1 comma 200 is the destination and 10 is the timestamp. So there is nothing to be confused, like here I have 10 as the timestamp, here I have 10 as the timestamp. There is no conflict at all here. The conflict comes at the destination port. That's why they gave get count in the destination. That means uh, the destination is how much busy the destination port or destination device is. So nothing to do with the timestamps. Remember this, nothing to do with timestamps. Right here I will return true. Here also I return true. Now let me strike this off, but before that, now I am striking this off. I am having 1, 210. Let me see, 1, 210. 1, 210. So I will return a false here. So I have this 1, 210 here. So I don't need it. I don't add a duplicate. So if it is duplicate, return false. That's it. So this is completed. Now let us see 220. 220. 220. No, I didn't get any 220 as a packet. So I'll do 220. This is the packet I'm gonna send. That means this is the packet that I have, right? So I will return true here. Now this is executed successfully. 220. Now I have 330. Every time I push this packet, I need to ensure is it exceeding memory limit? Not at all. I gave memory limit as 5 so that you don't confuse that memory limit is equal to the size of the packet. So add packet 330. Let me see, do I have any 330? So if you see, I doesn't have any 330. So let me push this 330 as a packet, right? Successfully added this 330. So let me return true here. Now I have 335. So if I add 335, then I'll get this as the packet and I will return true here. I'll return true here, but before that let me adjust this size, right? I have a true here and I have a true here. Now, yes, I have written true. So add packets are completed now. I think you got this intuition that how this routers works. Now forward packet. What does this forward packet mean? This means remove the first packet. When I say remove the first packet, that means this packet is sent to the destination. What does this packet and the destination and source is? Means this packet is containing some data. That data is sent from the source and to the destination through the router. Source to the destination. For example, you send a WhatsApp message of hi from your device from to your friend of another device like this. Then the data of hi will be sent, but there will be something like external information of what is the source we are sending from, what is the destination we are sending from, what is the timestamp, right? This is how it works, but let me not remove that. Yes, that means send the packet to the destination. So I have forward packet for one time. Let me see here. This packet is removed. This packet is removed from the router, right? So I have removed that packet and I need to return this as a vector int. Return this 110 as a vector int. Let me write it over here. Return the packet as a vector int. This will contain something like source, the given source, the destination, and also timestamp, right? That's it. Now this is executed. Of course, forward packet is executed. I have another forward packet here. So let me execute it again. 210. So if I execute it, I am removing it from the queue. If you see, I am pushing from the back and I am removing from the front. So forward packet is also executed. Now here comes the question. Get count 100, 15 and 50. Here we are given with the destination and start time and end time. Now what does this mean? So when we are asked with get count of destination and start time and end time, usually operating systems will use this like what are the number of packets that are waiting from start time to end time in destination device. So in destination device, something like your friend's device, what is the start time, what are the number of packets, or what are the data that need to be sent or waiting in a queue from start time to end time. That means here what are the packets in this start time to end time, but here there is condition of destination. That means how much busy this is done because of this is done to know how much busy a device is, destination device is. So let us see, destination device is given as 100 and the start time is 15 and the end time is 50. So the destination device is 100. So if you see, here I have 100, here I have 100, here I have 100. These are the destination. Remember it. These are the destination and this is the source and this is the timestamp. But I need to include only those which are starting from start time and ending to end time. That means in these timestamps, greater than or equal to start time, less than or equal to end time. Here 20, is it greater than or equal to uh, start time and also less than or equal to end time? 20 is less than or equal to end time is 50 and greater than or equal to 15. Now count will be incremented 1. There is one packet, so let me go to the another packet, right? Here I have 30. Is 30 is greater than or equal to 15 and less than or equal to 50? Yes, increment the count. Yes, this is also a packet which comes under the range 335. So 35, is it greater than 15 and less than or equal to 50? Yes, increment the counter. But if I am having something like 3, 200, 200 and 35, do I count this? Absolutely no, because 200 is not the destination that we are asked for. 100 is the destination we are asked for. Now, what are the data structures we need? So these types of questions need to know what are the data structures that I need. So something like, see, what I need, I'll write it here. I need what are the packets that are there in the router, right? I need what are the packets that are there in router, something like this, something to store packets, right? So I'll name it as scene so that I will know whether the current packet is duplicate or not or not. So I need something to store packets. That means I am naming it as scene so that I will know whether the current packet is duplicate or not. And I need destination and the timestamps that it stores. Something which stores which stores something like here. See, here the destination is given and what are the timestamp 1, timestamp 2, timestamp 3, all this, what are the timestamps it is storing, something like this, so that when I ask for something like, here we are given with get count of something here, then I need the destination where it is the destination so that I can iterate through the timestamps which are given with start time and end time, and I have the destination. So I go to the destination and go to the timestamps of start and end. I just return the count. That's it. Now I have forward. Forward. So what does this forward mean? Forward returns the first. I need the first one to be returned. First, something like first packet that need to be returned in a vector, so that, and when I am removing, I need to remove these from the other data structures too. So this is how I solve this problem. And so that something like, let me say I have these things. Now let me tell you that for this I'll use something like int and vector int, right? Here I have int and vector int, right? I'll store this. Let me name it as something like right, destination and timestamps. So I'm storing the destination and the timestamps so that, right, here I am using an unordered map. Okay, right, I have unordered map. I have named it as destination and timestamps, right? Now when I get these, I need this scene, right? Scene, something like scene. So let me not complicate it by using a tuple or vector int and searching for every time whether it is a duplicate or not. Let me hash this. Operating systems use this hashing method so that uh, a packet is a duplicate or not. So I will use scene and I will convert the given packet into a string and store it in this scene. So remember, I am changing the packet to a string by using hashing. I'll tell you how I do. And storing it in scene. That means these packets are there in execution. Now the thing is I'll go to the add packet. So first thing I'll do, if it is duplicate, how do I know is it a duplicate or not? Let me create a key is equal to, I will write a create key function from this source destination and also timestamp. So key will be created by using hashing. Don't worry, I'll tell you how this key is created. If it is duplicate, return false there itself. Yes, that's it. Now return true at the end, but before that I have this key inserted. That means I have destination and timestamps of destination. Here this destination is something like I have 100 and timestamp is 10. Then here in my unordered map of destination to timestamps, I have destination of 100. This destination is storing in a vector the timestamps it is having. So destination and timestamps of current destination is something like destination. Here we give it destination, right? Dot pushback timestamp. That's it. Now there might be a conflict that it might exceed the memory limit if memory limit is equal to packets dot size, right? Now how this packets dot size come in a way, here before here I will use packets which store stored the first incoming packet in in tuple, so that I'll tell you why it is storing in a tuple. Or let me not store it in a tuple, let me vector int, let me store it in vector int, right? I am returning true, but before that, if memory limit is equal to packets dot size, I need to do something. So first thing, remove the first packet using packets. Now I have the first packet, I got the source, I got the destination, I got the timestamp. Now I need to remove that packet from the destination to. So for that I'll go destination and timestamps of current, no, not current destination. So here the packet will be packets dot front and current or something like destination on timestamps of packet 1 dot remove or erase. I will be erasing the timestamp. The timestamp is packet 2. So what I am doing here, imagine something like I have 100 and something like the first thing is 1 and 1 is the source and 100 is the destination and the timestamp is 10. So 100 will be having, and there is another packet something like 220 220. So I'll remove the timestamp which is coming as 10. So 10 is erased. So if this packet, the front packet is removed, this needs to be removed. That's what I am doing here. Destination and timestamps of packet 1 is something like this destination. This destination. Go to this destination and erase packet of 2. So packet is nothing but here the front packet given in the router. I need to remove that packet in the destination too. That's it. I have removed it. Now I need to do yes. something like here I have created if this is for memory limit exceeding, right? And if it is a duplicate, I am removing it. But here I have pushed this, and packets need to be pushed this, push back this current source and destination and timestamp. And also I need to do another thing, that is I have this scene. So the current key is key, so I have created this key at the beginning. If it is a duplicate, I have written false, but if it is not a duplicate, scene dot insert key. That's it. This is how the algorithm for add packet looks like. Now let us see at the code. First thing, destination and timestamps, as I said, dequeue of vector int for the packets. So here I am using vector int. So packets which store the first incoming packets in vector. So packets are stored in vector int. The dequeue is used because the first one will be removed. First vector int, that means the packet will be removed. Now, since I think you understood this, now create key. When we are creating a key, we are hashing it. We are using a hash to convert this timestamp, this destination and source to a string, so that we will not go through the vector or any other data structure is not efficient. This string will be efficient. This is how create key function looks like. Now let us see at uh, add packet here. String key is create key. As I said, first thing we'll do is creating a key. If scene.count key, that means if this key is a duplicate, we are returning false. If packets.size is memory limit, as I said, this is the whole thing which we are doing. Old key is create key, packet of 0, packet of 1, packet of 2, and sorry, I have forgot this to mention, scene.erase old key. The key which is already stored in keys or scene keys will be erasing that in this function. And packet is packets.front, as I said. Timestamps are these. As we are using reference, that means going to the memory where it is, going to the place where it is, and removing something, erasing means we are going to the timestamps and erasing that from the destination and timestamps. It is equal to lower bound, and here this is the iterator to remove the it. That means first thing first when we got packet of 2, the first time when we got the timestamp. Now if it is not, memory limit is not exceeded, then packets dot pushback source, destination and timestamp. As I said, this is in a vector int. Now scene dot insert key and timestamps is destination and timestamps, and so this is the upper bound. That means here what are these upper bounds and lower bounds? Let me tell you that if I am having something like let me tell you the destination is 100 and it is having 5 as first timestamp, 10 and then 10 and then 20 and then 50. So the lower bound will go here and remove it, and when we need to push back it will go here and then create something like insert it here. So that's why we'll be using lower bound and upper bound. Now let us see what happens in this forward packet. It is same as the above one. we are doing we are we are doing execution, something like execution, that means removing a packet. Just we need to return the first packet, the first packet from packet from packet, that means the DQ. Now will be written, but what if it is empty? If it is empty, return empty. That's it, we will be returning an empty array. But wait, if we are removing this, the first one, I need to get the first packet, packets dot front. I'll be removing this from destination and timestamps. Remove from destination and timestamps, and also remove from scene. For that, I'll be creating a key by create key create key by using source is something that packet of 0 and packet of 1 and packet of 2, right? So remove from destination, remove from scene. So we'll be removing key from the scene. Is there anything that we need to remove? Destination and timestamps we have removed, and we need to dequeue from packets, the first one, and then first packet, return the first packet from the packets in an array. That means we'll be returning in an array. Let us see what is the code. Forward packet, as I said, if it is empty, remove it. Packet is equal to packets.front. That means the first packet. Now key is creating a key, packet of 0, packet 1, 2. That means this is the source, this is the destination, and this is the timestamp. Scene.erase key, that means firstly you can place it over wherever we need, but it should be before the return statement. Auto timestamp is equal to, this is the again the same code that we used here. If you see, this is the same code that we used here. We are using lower bound, so that lower bound of timestamps dot begin, that means the first time where we got this timestamp packet of 2, we are removing it. So this is how. And packets dot pop front, that means we are removing from the TQ. That's it. We will be returning the packet. This is already an array. Packets.front is already an array, and we'll be returning it. Now let us go to the last function that we need to execute, get count. Now, as I said, lower bound returns the first time we get a value. Upper bound returns the last time we get a value. So now we got another something like standard template library function, distance of lower bound, like something like lower and upper. This will return the distance between, the distance, or something like upper minus lower. That's it. We are using these three functions to get the lower bound of this destination. Sorry, where is it? So here, this destination, and lower bound is something like where we got the start time, and upper bound is something like where we got the end time. So let us see at the code. Timestamps are destination and timestamps of destination. Left is lower bound of timestamps dot begin, timestamps dot end. That means we are going through the timestamps of the given destination, and what is the first time we got start time. It is stored in left, and right is the last time we got end time. That means upper bound when we got the end time. Now return distance left and right. But you might say end time, if it is not present, then upper bound will be the value something like here. Let me tell you, here upper bound is given as 50 and lower bound is given as 15. Imagine there are some values of timestamps, and here imagine I have 30, 35, and then 60. Then here my upper bound end. That's it. This will not go after the end time. So this is how the code works. I have given the link in the description for this code. So go and check it. If you like this video, do share it to your friends and do subscribe to my channel. And the first question is already explained in my YouTube channel. So go and check it. Thank you.